Alright, welcome back. In this video, we are going to look at bounded sequence. Bounded sequence. Now, the word bounded is an English word, alright? And you have to know what it means. If we say that somebody is bounded in something, you should be able to know what that means. That means that you have no free chance whether to move upward or what, downward, or even not even sideward. Alright, so that is what we mean by what bounded. Alright, so when we generate it in sequence, what we are saying is that we say bounded sequence. So this means the sequence does not increase nor decrease. And you know what a sequence is? Sequence of numbers. It can be in AP or what? GP. Alright, that is the arithmetic progression and geometric what? Progression. So, and the sequence of numbers can be increasing or what? Decreasing. Sometimes you see it when it rises up, then it falls. Then it rises up, then it falls. Then it rises up, then it falls. We can get a sequence of numbers to be like that. Very good. So, what we are saying is that if a sequence does not increase nor decrease above certain numbers, then we are saying that it is what? Bounded. Alright, let's take note of these things. And if A of n, now A of n is a relation in terms of what? N. So A of n is less than or equal to capital N. If A of n is less than or equal to capital N, this means that it is bounded above. And if it is greater than or equal to n, it means it is bounded below. I will show to you graphically to see what I mean. And if it is between the above and the below, then we are saying it is what? Bounded. Very good. This means it can't go up, it can't go down, it just within it. So it means it is what? Bounded. Also take note that every bounded monotonic sequence is convergent. Every bounded monotonic sequence is convergent. Alright. So let's assume something here. Let's consider that this is the capital M, this is the small m. And this one is a bounded. This one is a bounded above. Bounded above. And this is bounded below. Bounded below. Right? So you can see the above and the below. So let's say that we have a sequence of numbers and it's from the least. Alright? It's from the least value like 1, 3, 6. Then you see it is increasing. So from the least value then it will be increasing till infinity. Then we are saying that this is bounded what? Above. It is bounded above what? M. It is bounded above what? M. Because this goes from the least till it gets to what? The M. So this is bounded above. But if it's from the greatest value and it's decreasing. For instance, 20, 15, 10, like that. This is decreasing. And when it gets to n, this is bounded below. So you should be able to analyze the two when we say bounded above and bounded what? Below. From the greatest to the least, and from the least to the what? To the greatest. Very good. Now what about the word bounded? Bounded. That is when we consider the true scenario. When we consider the true scenario, now we can see that this one gets to the m, then it ceases. And when this gets to the m, then it ceases. So with this, we say it is bounded. Alright? Very good. So that is what we mean by the bounded. So now let's look at some examples so that we will be able to understand whatever we are projecting here very well. So looking at the example, decide whether Should I write on board? Decide. Example. Decide. Let me write figure so that you can see it well. Decide whether the sequence is bounded above, is bounded, the sequence is increasing, decreasing, 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 or, and you know the increasing and the decreasing will be bounded above and the decreasing will be bounded below. So in other sense the same thing. Or not monotonic. Or not monotonic. Now the monotonic there means that this means whether the sequence is what? Bounded. So this means that whether the sequence is bounded or what? Not. Alright? Because if it's not increasing and if it's not decreasing, then you have to know what it means. Alright? That means that it will be what? Monotonic, whether increasing or decreasing. Very good. So this means in brackets, this means whether the sequence is bounded. Very good. Alright, so let's go straight to the point and solve questions. The A of n, or the relation in terms of n that we are going to consider here, is 1 over 2n plus 3. 1 over 2n plus 3. Alright. Now, the first thing to do now is to generate sequence of numbers for this relation. Is to generate sequence of numbers. So what we do is that we know that n is 1, 2, 3, like that. It continues. So let's start. If n is 1, what will you get? So this. If n is 1, you get 1 over 5. If n is 2, you get 1 over 7. We are making it a series. Then we get 1 over 9. If n is 3, if n is 4, we get 1 over 11. Or let's make it a sequence. No, we are doing sequence. So it continues like that. Very good. Now I want you to analyze something here. Is this increasing or decreasing? Is 1 over 5 less or greater than this? Alright. So simply, you can see that when we start inputting the value, here is when n is equal to 1, n is equal to 2, n is equal to 3, like that. So it is like n. Then you start by adding n plus 1. I hope you can see that. Then n plus, you see, that is how we were generating it. Very good. So we can see clearly that greater than this, this is greater than this, this is greater than this. So this means that our sequence of numbers here are decreasing. They are decreasing. But the important thing is that just the sequence there is not the final, it's not the final thing for you to decide whether it is truly decreasing or not. So we have to go and show what working. So what we mean is that the more we add plus 1, when we start adding a of n plus 1, when we start adding, the values that we are getting is less than or equal to what? The a of n. It's less than or equal to what? The a of n. That means that the a of n is greater than a of n plus what? 1. Alright? So this means that this is greater than this is greater than that. It is like that. So that is what this means. I hope it's clear now. Now we know that a of n is 1 over 2n plus 3. an plus 1 is equal to 1 over, now we are increasing the n by 1, so 2n plus 1 plus 3. In the same way, it's the same as wherever you see n here, put n plus 1 there. So by substitution, we get 1 over 2n plus 1 plus 3 less than or equal to 1 over 2n plus 3. So by cross multiplication, we get 2n plus 3 less than or equal to 2n plus 1 plus 3. Very good. So here we get 2n plus 3 less than or equal to 2n plus 2 plus 3. So here we get 2n plus 3 less than or equal to 2n plus 5. So you can now see that the 2n is the same as the 2n here. Alright, so no matter the number you multiply by a 2 and add by 3, what you get here will be added by 5. So this will be greater than what? This. I hope it's clear. This will be greater than this. In the normal sense, what we mean is that this is going to be greater than that, and that is that. Very good. Alright, so here we can continue to also say that 2n plus 3, all this over 2n plus 5. In case you can still see that, here you can replace any number here. Let's replace here by 1. 1 here you get 5 on top, 1 here you get 5 over 7. Alright? And you can see that 5 over 7 is less than or equal to what? 1. So if you replace n by 2 again, no matter the number you are going to replace here, it's going to be less than or equal to what? 1. Very good. It's going to be less than or equal to that. So this is telling us something. This is telling us something. And what this is telling us is that, so a of n, which is 1 over 2n plus 3, is monotonic decreasing, monotonic decreasing. Alright, I hope it's clear. It's monotonic decreasing. In the same way, it is bounded below. It's bounded below. That is in other words. So it is bounded below. It is the same as monotonic decreasing. Alright. Now, let's see. That is not all. It is bounded above or bounded below. So this monotonic decreasing. So what value is it bounded above? And what value is it bounded below? Very good. So here we can see that what we have is bounded above, bounded below. So you can see that it is bounded above a of n less than or equal to. It is bounded above what? This, because it is from this, then it starts decreasing. Alright? So from 1 over 5, then it starts decreasing. So it is bounded above 1 over 5. 1 over 5. Alright? So it's like this. So it starts from the 1 over 5. That's where it is bounded above. Then it is bounded below. Don't forget, it's not bounded below 1 over 11. It can continue till. You can even put n to be equal to millions of thousands. So it will definitely going to be bounded below, bounded below 0. It's going to be bounded below 0. Bounded below 0. And it will not be even greater than or equal to, because it can also get to the negative value. So that is how it is. That's how it is. So lastly, now, how will I know whether this is going to be bounded below 0? Another way to know that this is bounded below 0 is to take the limits. Take the limit as n approaches infinity of a of n, which is the limit as n approaches infinity of 1 over 2n plus 3. Alright? So when you take the limit of this, what will you get? Hope I remember how we do it. You take 1 over n over 2n over n plus 3 over n. This will go infinity, you get 0. This will go 2 cancel 2 over n. Okay, here we get 2 plus this goes 0. So final 7 is 0. So by taking the limit, we can also see that this one will go what? 0. This one will go 0. So that is what we are going to get for that. Very good. I think that is all that I have for you in this video. But you know what? I can't end it without giving you a question to go and do. So I would like you to go and try on this. I'm going to clean this side. You are going to do the same thing. Decide whether 1 a of n is equal to n negative 1 raised to 1n. Going to do it in the same way. 2 a of n is equal to 2n minus 3 over 3n plus 4. 3 a of n is equal to negative h square n, then 1 over n squared. Please, don't fear for this. Don't fear for this one there. Alright? It's telling us something, okay? Because, for instance, let's look at something. Let's assume we have a of n is equal to negative 1 over n, 1 over n squared. Or not that, 1 over n. Or let me use 1 over n. Now, if you put n to be equal to 1, what will you get? You see that we have a negative here, so if it's raised to the power of an odd number, the result we are going to get is what? Negative. And even number, we get it to be positive. So if n is equal to 1, we are going to get 1 over 1. How we can see that? If n is equal to 2, sorry, we get negative 1 over 1. But if n is equal to 2, we get here to be what? A positive. Here to be positive, then we get half. If n is equal to 3, here is odd. So we get negative 1 over 3. So we get it like that, 1 over 4. So here to be positive. Here to be negative 1 over 5. Then it continues like that. So you can see the type of this what? Sequence. When it decrease, increase, decrease, increase, decrease, increase, because negative value, positive value, negative value, positive value. So this is, you can see, it's neither bounded above and it's neither bounded below. Very good. Go with this. Look at the type of sequence it is. It's neither bounded above and it's neither bounded what? Below. So this is just bounded. This is just bounded. How we don't see that? It's just bounded, and when it, that's what we call it alternating what? Sequence. So this is what? Alternating. It's alternating like that. Very good. See you in our next video, where we are going to start solving some questions relating to this.